As mentioned at the end of the last video, I want to use a server power supply as a bench power supply. Proper bench power supplies are quite expensive. I've got enough things to spend my money on. You might think to yourself, well, a server power supply is probably really expensive. And if you were to go out and buy one of these things new, yes, absolutely, they're expensive. The reason why they're cheap in this context is that servers don't have a very long shelf life. After about 5 years, even the best servers are pretty much worth not much more than scrap value. So it means if you buy an old server, you can rip the parts out of it and get really good, really high quality components for not a lot of money. And that's exactly what these are. These are power supplies that came out of servers from my day job. I imagine you could probably find them on places like eBay, Kijiji, Marketplace, Facebook Market, whatever your local selling site is, for probably 50 bucks. That's Canadian. Translate that into your currency. Anyways, these things are designed to run for years after years after years of continuous operation, and they're meant to do it reliably. So as a power supply, these things are really high quality. So in a lucky world, you can find a power supply that somebody has already documented how to turn one of these things on. They don't turn on as soon as you plug them into the wall. They have to have pins shorted or resistors added that tells the power supply, go ahead and turn on. Normally that's handled by software on the physical server. Obviously, the physical server isn't here anymore, so we can't do that. I'm in a situation where the particular power supply I use, I have not been able to find documentation on it at all. So the first step of using this is I'm going to have to crack this thing open and try to trace the pins and figure out what each of the pins do. That big cylindrical thing, I don't know if you can really see it because it's taped up, that is the capacitor. That is what's going to give you a very, very bad day. If it's charged up, this is a big one. It can absolutely ruin your day very quickly. And while we're looking, this here, this here, this here, these are all different capacitors. All of these can give you a bad day. There's another little cylindrical one down there, if you can see it. You can see the side profile of this one. All of these are going to hurt very badly if they happen to be charged out and you short them out. So again, don't be afraid to open up something like this. Just be very respectful of what you're dealing with. So you can see that. It says ground and plus 12 volts. So that confirms which are the two I want to pull from when I get this thing fired up. The trick is now to figure out these other 9 pins. Being extremely careful about what I touch. Another trick when you don't know what the pinout is, a lot of times the companies that make these power supplies for other companies like Fujitsu, they make them for a lot of things, or for a lot of different customers. So I'm looking at the silk screening for any kind of a number that might give me a clue as to what power supply this is. So this power supply might be used by 10 different times. So I know the company that built it is Delta, and I see a few other keys here like 2950, 258, 306. That's probably a serial number, that's probably not a model number, but I'm going to try to search for it. I see some more part numbers. These are probably more useful. I see DPS 450SP. That could be useful. 250V, DPS-800 NBXX. I know that this particular server came in 2 variants, the 450 watt variant and the 800 variant. I am willing to bet that the DPS is dual power supply, the 250V is that it supports up to 250 volts, and then 800 watt variant, and I can see a mark over it, NB. So with that, I bet you I can probably get a lead now on a pinout. All right, so no luck searching for the part number. The traces are not easy to follow. This is the backplane cage. Hoping there might be more information here. Why is it not coming out? Looks like it might have to slide. Ah, yep, that was it. All right, so there's the two edge connectors that the power supplies would normally connect into, like so. So I'm hoping if I can get at the circuit board, I can see exactly what is what. Oh, oh, flip yes. All right, okay. Ah, this is awesome. This looks like a bog standard ATX connector. If nothing else, it's color coded. Oh, come now. Oh, this is excellent. Okay, so I can probably get the pin out, come on, for this thing. And then simply use a probe, a continuity tester to figure out which wire goes to which. Oh, flip, yeah. Okay, and there's the pins for that. Ooh, I think we're making progress. And if you're thinking, holy crap, this looks complicated, there's no way I could ever do this, oh my God, I'm really just kind of a glorified idiot that plays like she knows what she's doing. Don't be put off by this. Again, the only thing you have to be careful of is capacitors. Obviously, when it's unplugged. If it's plugged in, then you have a lot more to worry about. But, you know, we all have reasons of our stupidity. Reasonable limits to our stupidity. Anyways, point is, this might look complicated to somebody who's never used it before or never seen inside of a server before, but really ain't not much. Back when I first got started, I used to see these kind of things and think, oh my God, you have to be a genius to be using them. No, you don't. They're actually really simple. One of the perhaps most useful components is something, or features, is something called a continuity tester. And all that does is beep if there's a connection. So if I want to see where a wire goes, I can stick, so say I see there's the black pin here, I'm gonna stick a black pin in, and I'm like, oh, is that connected here? Yes, it is. So it's a great way to find traces. Traces, just a fancy way of saying the wires. Look at that! 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 Oh, how did I not see this before? Okay, I don't know if you can see this, but can you see that? That lovely, lovely magic right there? Oh, probably not. Anyways, it actually says white with yellow stripe, plus 12 volts. Oh, I love silk screening so very much. Ah, whoever did this, thank you. If you happen to work at Siemens or Fujitsu and you did this, mwah, chef kiss. So that must mean one of these are the signal pins that tell it to go ahead and turn on the computer. I'm starting to get very happy here. I'm gonna figure this out. This is gonna work. I mean, I'm not quite sure exactly how yet, but that's okay, details, we'll figure it out. Plus 12 volt LS, I'm guessing that's low power standby. I could be totally wrong. Oh, this is good, this is good. Oh yeah, I'm gonna get this figured out. I'm starting to have more confidence. Okay, I'm going to pause here and go back to trying to trace things out. But yeah, generally, all I'm gonna be doing is toning out. So if I go like, say for here, I can go like this. Look at that. I found the pins connected to whatever that is on the other side. And there's those. So this looks really, really complicated, but it's not. It's actually really, really simple. It just takes a little bit of time. Think of it like making a treasure map, except out of electrons. All right, after all this time, I have managed to trace a sum total of 3 pins on the bottom side, and that's it. I don't know if you can see that or if it's washed out. So I'm going to try something now, and as much as I'm reluctant to say, don't try this at home, this is one where I'm going to say, don't try this at home. What I am going to do is I've got a power supply outside of the server. It is now plugged in. I can see that the light is blinking. Now at this point, in theory, I'm dealing with live voltage. So it's time to get careful. I've got you on camera, so if I blow myself up at least, I don't know, maybe to be interesting internet content. So I'm switching my multimeter to voltage DC. Now I'm touching what I know is the 12 volt, but it should be dead. And sure enough, it's showing 0.001 volts. So now I'm going to what I'm calling pin 9, and I'm seeing 2.9 volts. 2.9 volts. Pin 7 is nothing. Pin 6 is nothing. Pin 5 is 3.3 volts. That's a standard power supply voltage. 4, 3.2, nothing, nothing, nothing. So what I'm going to do is I'm switching it to continuity, and I want to see if pins 4 and 5 are shorted together. No, they're not shorted out. All right, flipping it over. So now I've got green or ground. Checking the bottom 12 volt, it should still be nothing because the power supply's off. Oh shit, I've got it in. Don't be an idiot like me. Okay, let's try this again. Nothing on the 12 volt. 3.3 on pin 9. 8 is 3.3. I know pin 7 is the 7 volt standby. It should be anyway. Or sorry, 12 volt standby, and sure enough, there's 12 volts. Okay, so that's good. 4 is 0.1, it's basically stray. 3.3 volts again on 1, so 9, 8, 7, 6, what I call 5 and 4. I'm saying I say pins X, Y, and Z because I don't see a pinout numbering, and every company actually has a pinout assigned. So I'm sure that it's different for whoever made, or for Delta, but I can't find their spec, so I'm winging it. All right, so now the next one is the pin 3, nothing, and then I should see continuity on these two because they're ground. Yep, they're ground. All right, so now I'm down to pins 1, 2, 3 are unknown, 6 and 7 on the top, and 3 and 6 on the bottom are unknown. I got a little bit better understanding of now what's going on. So chances are I'm going to pull one of these 3.3s to ground and the system would power on. I just don't know which ones.
You should keep
Hello,
track of
YouTube.
How much whiskey you drink during this project.
No, there's some questions that are best left unanswered. That's one of them.
I think you're trying to actually become a pirate.
Okay, so I'm going to solder this to ground, right?
Yep. Tin the wire and tin the pad first, and then join them together.
Oh, okay. Okay, the wires.
Once you've got a pad and it's tinned, then you don't need to add any more solder when you join them together.
Okay, well, officially fucking this power supply. Yeah. Okay, so I think I've got too much thermal mass here because it's not actually heating up the pad, and the pad is huge. Should I turn up the thing?
No.
So just wait until they... Holy fuck, this is just... I've got a big blob on this pad, and it is just not melting. Oh, there we go. I had to rotate the tip.
Yep. More surface area.
Holy fuck, I cannot melt this to save my life. I can feel the heat coming off of it. I am frightened now of how much it's going to take to get the heavier gauge wire on for the XT60 connector.
Well, if you're doing heavy duty stuff like that, you may want to get, if you're doing like big bus bars and stuff that you want to solder onto, then you need a different soldering equipment for that. Soldering onto big metal components like chassis and things, even though this is a temperature controlled station, it still doesn't have unlimited power, right?
Yeah. Like I'll get little localized bits of melting and then it hardens right up again. Well, you know what? This is on tight enough. I'm going to put another lead on the other side.
Yep. Is that on the big grounding part?
Yeah.
Okay, so this one now, don't solder the other wire on. Just touch it to try it.
Oh, I was just doing this so I had a lead that I could muck with. So because this is so big, right?
And once you're sure that it's good, then you can solder it on there all the time.
Yes.
Well, not with. Don't use that resistor because that's a waste of like $3.
Oh yeah. No, Well, would I need a resistor or could I just do a dead short? I know with traditional ATX power supplies.
So what's on the other end of that kind of circuit generally is called what's called an open collector.
Yeah.
Which is the collector lead of a transistor, where the emitter is grounded. Open collector means that the other side can be at pretty much any voltage up to whatever the max for the transistor is.
It's just enough to switch it.
All it does is it just pulls down on it. Inside the power supply, there's a resistor pulling up on it to keep it in a known state when it's disconnected.
All right.
And when you activate the transistor, it pulls that down to ground, and then there's a sensing circuit inside that switches it on.
I should probably get a power bar that I can quickly turn off in case things go sideways, right?
No, it won't go sideways, don't worry.
I love your confidence. Okay, I've got my foot wrapped around it, so if I need to, I can rip this out in a hurry.
No, don't worry about it. Just touch it and just make sure you double check which one you're touching. Even then, you're going through a large resistor. Like even if it goes on the rail, like even if it's the 12-volt rail, it's not gonna hurt anything.
Okay, you heard that. I wanted to go to, I think it was A21, yep, which is the 5th pin in. So 1, 5. 1, 2, 3, 4, 5. Here we go.
Yep.
Nothing.
Nothing.
I'm scraping back and forth just in case there was any kind of oxide. Nothing.
That's unfortunate.
Now, wait a second. Did I plug in the right output? Hold on a second. Nope, I'm a dork. In case you were wondering if I'm really an idiot and new at this shit, the answer is yes, very yes. Okay, make sure it's actually blinking this. Okay, now I've got a blinking light. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Nope. Nope.
Okay.
I could try dead shorting it.
Yep. Try that, but I don't think that'll fix it.
No, neither do I. Nope. No bueno. What I have done is shorted B21 on the back over to A21 on the front. And then that has gone to a switch, and the switch goes over to the ground plane. With that, I should now be able to plug in the power. You know what, I'm going to put on my glasses for this just in case anything decides to go pippity-poppity poop. I should be able to plug this in, and the switch is currently in the open off position, so nothing should happen. Okay, see how it's blinking? That tells me that it is off. And now the fan should turn on, and the light should go solid. Ladies, gents, and others, we have a working bench power supply that is controlled by a switch. This makes me very happy. Okay, next step. Okay, now, this is going to be a little tricky because I have already seen how hard it is to get enough heat into these pads to melt the solder. So I fear this is going to be tricky. There's a lot of mass to get heated up. Come on, try to get the heat down in there. Get onto the bus bar, or pad, or whatever the hell it's called. I'm not getting a good, ow, I am not getting a good connection here. Okay, let's see if I can preheat the bottom. Maybe that'll work better. Okay, I'm scared I'm going to damage something. I'm turning this back up to 750, or back down to 750, I should say. So you'll notice by another wardrobe change that this has been a multi-day effort. So the last thing was trying to solder the XT60 connectors onto the power supply. But this little, though accurate, soldering iron just didn't have the power to heat up the large pad and the end of this wire well enough to get it connected. So part of the delay was ordering a much larger, I've not even taken this out of the box before now, solder gun. So the way this works is it's got two trigger positions. When you go all the way in, you can see the light comes on, it goes to 200 watts. If you pull the trigger only part way, it goes to 300 watts. That's a lot of heat. So I'm going to try 200 watts first. And because this is going to be hot and I don't want to burn my table, I've got this little piece of wood to put the soldering iron down. It's not like this one where you have a home for it. Let's try melting this. Oh, wow. Okay, yeah, this is going to have no problem, even at 200 watts. Oh, the joys of having the right tools. Holy crap, is this a lot easier than last time? All right, this is not winning any awards, but then again, it doesn't need to. All right. One of the other things I'm going to do, I don't know if you can see this, I'll take the other XT60 connector. I may have showed this earlier in the video, I don't know if I've included the clip or not, is that it comes pre-tinned. Now, what I've been doing is cutting that tinning off and then fanning it out. So, even though these aren't going to be soldered onto here, I can show you this. So what I've done is I sort of fanned it out like that before I attached it onto the pad. Now I'm going to, oh, wow, I'm really glad this is lead-free. That's a lot of smoke. Okay, see how it's pulling away right now? I want to try to reposition this in such a way that it wants to hold down naturally. I'm not quite sure how to do this. Oh, I do so love being new. Okay, that seems to be holding down relatively well. Get lots of solder ready. And again, I'm on the 200 watt setting. And given how fast this is melting, I can't even imagine what you would need 300 watts for. Okay, that one actually came out a lot better. So much better, in fact, that I want to try to hit this one again. Ow! Ooh, that's hot. There's been times through this where I got really frustrated, thinking, I am not even close to smart enough to be doing this, who am I kidding? You know, the usual stuff. And I'm really glad that I got over that, because that is just not the case. There's a difference between not knowing and learning and not being smart enough. And I have to remind myself of that. All right. And that, ladies, gentlemen, and others, is that if I've done this right, I should now be able to plug this in and get 12 volts. Okay, so that's plugged in. And now I should have 0 volts right now. Zero volts. All right, survey says, oh, why does this make me nervous? Woo! 12 volts. And you can see the capacitor's draining down. Now, the reason I turned it off so fast was, oh, I had a short between the two. Woo! That's not good. Okay, I'm going to fix that. How the hell is GoPro still in business? You'll notice that I've covered all of the pins with capsin tape. Capsin tape is a type of high temperature tape, so it'll keep its stickiness even if the system gets hot, or the thing gets hot, which this will. I also put some rubber feet on the bottom of this so that I don't hurt my desk. I think that's enough for now. The next video we'll talk about actually setting this up and using this to do a top balance. So, thank you for watching. I'm the Digital Mermaid. This process can be, it requires patience sometimes, but it's going to be worth it in the end. And onward.